Alrighty, hi there, geometry folks. So today we're going to go through some of the extra practices and some of the optional questions that are going to be on Canvas that are basically going to revolve around the different transformations and the basic and the extra transformation practices. Like I said, I think I said this with the previous time that I recorded one of the practice videos, is that I'm not going to do all of these because there's obviously, you can probably see from here, there's like five pages for this particular assignment. But the goal is to give you all practice. The goal is to give you all exposure to the types of questions that you're going to run into on the assessment and the types of practice questions that you're going to run into with the different assignments, and just to get you to the top of your game, basically. So I'll do like 3 of these because this is basically just 2-step sequences. This is what we did. This is what the worksheet was when we were doing those. This is just more of the same. So let's go ahead and get started. So we have triangle ABC. I'll get this centered on the camera. There we go. We have triangle ABC, and it has vertices at -3, 2, 0, 4, and 2, 1. We have to translate this triangle ABC by vector 4, -3. What are the coordinates of A prime, B prime, and C prime? Alrighty. Well, A prime, if we're translating this by a translation vector of 4, -3, remember when you're using a translation vector, the sign, the first digit, the first number is going to be X, the second number is going to be Y. The sign of what the number is going to tell you whether you're adding it or subtracting it. So in this case, we're going to be adding 4 to every X variable, and we're going to be subtracting 3 from every Y variable, just for this first translation. So 4, 3, starting with A, 4 plus -3 is 1, and then -3 plus 2 is -1. B prime, 4 plus 0 is 4, -3 plus 4 is 1, and then C prime, 4 plus 2 is 6, and then -3 plus 1 is -2. Now, if only we were doing a single transformation. Now we're going to be rotating this 90 degrees clockwise about the origin. Now, the transformation with translation vectors is, easy because it's written on the parameter how you're going to be changing it. But with the rules of rotation on the back wall here, that's the best way to remember how to do different types of rotations and orientations. So clockwise about the origin, transformation for that one, as a reminder, is that for X and Y, you're going to rotate it, and it's going to be 100% before I write this down. Yeah. Becomes Y, -X. So when you start with at whatever your X is, it becomes whatever your Y was, and whatever your Y was, it becomes what your -X, it becomes old X. So it sounds like you're describing like a grandpa at a rest home. It's a old X, but it's, anyway. So we've got these points here. We've got our transformation, so let's see what we've got. A double prime. So X becomes Y, so -1. Y becomes -X, so -1. All right. For B double prime, X becomes Y, so 1. Y becomes -X, so -4. And then finally C prime, X becomes Y, so -2, -2. And Y becomes -X, -6. And so this would be your final answer with the 2-step rotations. So the 2-step rotations aren't any more complex than some of your other rotations. It's just that you're doing one, and then you're doing the other one. So the hardest thing, especially with the worksheets that I saw that you all turned in, the hardest thing is that sometimes the wording was different. The wording was difficult or wasn't entirely clear. And I'll do the best I can to prepare you for that. But again, I only write some of these worksheets, not all of them. All right, let's go with rectangle PQRS. It's got some vertices. We're going to reflect this over the y-axis. So if we're reflecting something over the y-axis, the y is going to stay the same. I'll just write this down here. The y is going to stay the same, but x is going to be negative. Or not so much x is going to be negative, but you're going to switch the sign of whatever x is. So let's start out with p prime. Y is going to stay the same, but x is going to be negative, so that becomes 6, negative 2. Q prime. Y stays the same, but x becomes negative, so that becomes positive 2, negative 2. R prime. Y stays the same, so it's 1, but x becomes negative, so that's again 2. And then S prime. Y stays the same, but x becomes negative, so negative and negative gives you positive 6. There we go, something jumped there. So that's the first transformation. Now we dilate this triangle from the origin with a scale factor of 0.5. Now remember, when we're working with scale factors, we have k equal to 0.5. What that means is that for every x and y, the dilation transformation is going to be k times x, and then k times y. So you're taking this k factor, which in this case is going to be 0.5, and you're just multiplying every single number by this k factor, and that becomes your transformation. So p double prime, that will bring me 3, negative 1, because I'm basically just taking, multiplying this by 1/2. I'm just taking half. I'm just multiplying it by 0.5 means I'm dividing it by 2. I'm taking half of this. So I can do most of this with just regular mental math. Q double prime is 1, negative 1. R double prime is going to be 1, 0.5. And then S double prime is going to be 3, 0.5. So again, the sequence, the two-step sequences, not too rough, not too difficult, not too challenging, especially for a group of smarties like you all. Let's do one more, and then I'm basically just gonna call it, because at this point, what else do we really have to prove, right? All right, so we've got W, X, Y, and Z. Step 1, rotate quadrilateral 180 degrees about the origin. Well, I remember this one. I remember this transformation pretty clearly. If you rotate something 180 degrees, all you're doing is you're taking whatever the x is, whatever the y is, and you're just switching their signs. So just to write it down, whatever your x and y was, it becomes negative x, negative y. So let's start with W, rotating about 180 degrees gives me negative 1, 4, W prime. Then I've got x prime, which gives me negative 4, 4. Y prime, which gives me negative 3, 1. And then Z prime, which gives me 0, 1. All right. Now I have to translate this quadrilateral by vector negative 2, 5. So what it means is I'm going to be moving it to the left 2, so I'm moving it to the left 2 spaces, and then I'm moving it up 5 spaces. All righty, so let's get started on that. W double prime. If I'm moving it to the left 2 spaces, that means that this becomes negative 3. Moving it up 5 spaces means it's 9. X double prime. Moving it to the left 2 spaces, so that's negative 6. And then up 5 spaces also makes it 9. Y double prime. That was too much like a C. Y double prime. If I'm moving it to the left 2 spaces, that gives me minus 5. If I'm moving it up 5 spaces, that gives me 6. And then finally, Z double prime. 0, moving it to the left 2 spaces, negative 2. And then 1, moving it up 5 spaces, is 6. So as far as the assessments go, as far as the assessments are concerned, you do need to be able to draw these, but I think drawing them is going to be secondary to getting the transformations right and getting these coordinates correct. And so with that, it's just going to take practice, it's just going to take work, going one transformation at a time, and then keeping track of what your points are. That should pretty much do it for the extra two-step practice. Like I said, there's another 4 pages of this if you really want the extra practice. If you do, then by George, you'll be magnificent at this. If you don't, that's perfectly fine. I constructed the worksheet so that you just needed the ones we did in class and you'd be fine. So either way, I'll see you at the next video.